Okay, so much like last time, the column space is the linear combination of the columns of A instead of the rows of A. So let's look at, again, our matrix from our previous example. And this time we can specify the columns of A, in which case we have 3 as C1 equals 1, 4, C2 equals 2, 8, and C3 equals 3, 12. So we can say that the column space of A is equal to the span of C1, C2, and C3. Yeah, we can also say that the columns of A span the column space. So let's figure out a basis for the column space of A. And this is a little more complex than the row space of A because of the fact that the column space of A is not equal to the column space of its reduced row echelon form matrix. And the proof of that is really long. Actually, no, the proof of something else is really long, really complex. But we will quickly see how these two are not true. How this is a true statement. Sorry, how these two are not equal. So let's say, let's take our reduced row echelon form matrix again. 1, 2, 3, 0, 0, 0. And here we can see that the column space of R is equal to the span of 1, 0, 2, 0, 3, 0. And we can very, very easily see how this is not equal to this because of the fact that there are zeros here. So how do we find the basis for the column space of a given matrix A? Well, we have to reduce it down to row echelon form. And the columns with the pivots in the reduced row echelon form matrix correspond to the columns of the basis of the row space of A, of the column space of A. So in this example, we have that only one of our columns is a pivot, so the basis for a column space of R is equal to 1, 0. And the basis for the column space of A is equal to the corresponding column, so in this case R, 1, 4. So that's how to figure out a basis for a column space. Now let's look at an example with more than one. This wall is really hard to erase. But let's take a matrix B in right now and set it to 3, 4, 0, 7, 1, negative 5, 2, negative 2, negative 1, 4, 0, 3, 1, negative 1, 2, 2. Slightly bigger matrix, and doing some row operations, we get the corresponding reduced row echelon form matrix is and the last row becomes a row of 0, so it just drops out. So this is our reduced row echelon form matrix. We know that the basis for the column space R is the three rows with pivots. So therefore, the corresponding 3 rows of B form the basis for its column space. So we have 3, 1, negative 1, 1, 4, negative 5, 4, negative 1, and 0, 2, 0, 2. And the proof that the basis for the column space of R corresponds to the basis of the column space of a matrix is really long and really complex, and I will not go over it here because it takes about maybe half an hour to prove. But that is the column space. It is basically the row space, except on the columns with a slight caveat about finding the basis.